Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to write functions in multiple ways and recognize function notation, how to recognize patterns in functions to determine whether or not those functions are linear, how to recognize coordinates in terms of x values and y values, how to plot points on the coordinate plane, how to recognize patterns in the graphs of linear functions, how to determine how the slope and y-intercept will affect the graph of a function, how to find a function value of a linear function, how to find the slope and y-intercept of a function from an equation, how to take linear equations that are not written in slope-intercept form and convert them to slope-intercept form, how to graph linear functions using slope and y-intercept, how to manipulate the slope and y-intercept to change the steepness and location of a graph to suit the needs of a question, how to recognize practical applications of mathematics within your areas of interest such as basketball, how to find the y-intercept of a linear function given the slope and a point on the line, and how to find the equation of a line given the slope and a point on the line. How are we learning it? Through the Linear Functions MYP Assessment assignment. When can we use this information? To recognize patterns in your spending so that you can figure out how to save enough money to buy a car, to determine the location of appliances, furniture, and walls when planning to remodel your house, to determine how long it would take to save up enough money for a down payment on a car, to calculate the amount of money in a savings account, to change the appearance of difficult tasks so that it looks more like something you are used to seeing, such as changing your grocery list into a list based on the aisles where you will find the items, and to improve your ability to read between the lines and fill in gaps that are not given, such as putting together a bookcase with directions that are incomplete. How do you know you learned it? By getting a score of 4 on the Linear Functions MYP Assessment assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. Next, we'll do our weekly raffle. After that, I'll give you time to complete the Linear Functions MYP Assessment assignment on Desmos. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to continue working on the linear equations and inequality study guide and any incomplete assignments that you may have. Let's take a look now at the Introduction to Functions notes. Our notes begin with the learning goals and success criteria. Now let's talk about the components of a function. A function is a relation in which each element of the domain is paired with exactly one element of the range. The domain is all of the input or x values in a function. The range is all of the output or y values in a function. Therefore, a function, meaning that for every x, there's exactly one y that matches it. So in looking at this, we're given a table here, and we're supposed to pick out the range and the domain of each of these. So first we'll do the domain, the input values. Well, our input values in this case is the month, so we're just going to list the values that apply. Well, we can see that the values are 1, 2, 3, and 4, so that is our domain, 1, 2, 3, and 4. The range are these values here. So our range would be 2, 4, 6, and 8. So we have our domain, we have our range. Let's try another one. So here we have 0, 2, 3, and 6 for months. That is our domain. And our range comes from this column here. So we would have 6, 3, 4, and 8 as our range. So that's domain and range. Now, understanding functions. Notice here, we have a domain here, and we have a range here, and they're mapped to each other. So when x is 2, y is 8. When x is 3, y is 12. When x is 4, y is 9, etc. And the question is this a function? Remember, in order for it to be a function, there has to be one y for every x. So if I look at this, I can see that my 2 is only mapped to 8. I can see that 3 is only mapped to 12. 4 is only mapped to 9. And 5 is only mapped to 17. So therefore, this is a function because there's no split. I don't see 2 going to 2 different places. Let's look at another example. We have a domain here. And notice now, the question is this a function? We have the domain here and the range here. And notice 2 is mapped to both 8 and 12. So therefore, this is not a function because 2 is mapped to two different places. Remember, for every x, this is our x, for every x, there can be only one y that goes with it. 4 and 5 are okay. 3 is actually okay even though it's not mapped to anything. The issue is 2. Okay, let's look at another example. So this one says for every number in the domain there can only be one number in the range. And is this one a function? Well, we have 2, 3, 4, and 5, and 2 is mapped to 8, and 3 is mapped to 8. So there's two numbers going to 8. The question is that okay? The answer is yes, it is okay, and this is still a function, because 2 is only with 8, and 3 is only with 8. It doesn't matter that they're both going to the same place. The issue would be if x is mapped to two places, but each x, 2 and 3, are only mapped to one place. They're just mapped to the same place. So yes, this is still a function. How can we tell if something's a function by a graph? Well, we use what we call the vertical line test. So again, for every x, there can be only one y. So if I pick an x like 5 here, I can see that when x is 5, y can be this number here, whatever that is, maybe 14 or so. And y can be here, which is -4. So in this case, this would not be a function because there's two numbers. Now the easy way to check this is what we call the vertical line test. I can draw a line anywhere on the graph, and if I draw the line anywhere on the graph and it touches the graph in two places or more than one place, then it is not a function. So I can see here, I drew my line in and it touches there and there. So when x is -10, this is not a function. So therefore, it's not a function. And if it only happens once, it doesn't matter how many times. In this case, I can draw a line almost anywhere and it's going to be not a function. But if there's even one place where I can draw it and it's not a function, then the whole thing is not a function. Now what about this one? Is this one a function? Well, let's take a look. Is there any place I can draw a line? Notice I drew several lines in different places, and no matter where I drew the line, it still only crosses in one place. So even though the graph looks really funky, right? It goes up and down and up and down. I still can't cross in two places, so therefore this is a function. Okay, functions can be written in two ways. We can call it f of x equals some function, right? I can write the equation for the function there. Or I can say y equals some function. So you probably heard the term y equals mx plus b before. Well, what I'm telling you here is that it doesn't always have to be y, it could be f of x. So f of x equals mx plus b, and that means the exact same thing as y equals mx plus b. From that then, I can find a function value that corresponds to the domain value of some number, which in this case I'm going to plug in 3. So let's say I gave you that f of x, or it could be y equals, right? F of x equals 2x minus 3. And I want to know what happens when the domain value is 3. Remember, the domain is x, so I'm going to plug 3 in for x. So this becomes 2 times 3 minus 3. Now I solve, so I'm going to multiply 2 times 3, and I get 6. 6 minus 3 is 3. So when x is 3, y is also 3. And if I were to plug in any other number, so let's say this was 4, I would just plug 4 in for x. If it was -8, I would plug -8 in for x. So whatever number they give you, that's the number you plug in for x, and then solve. Linear relations. What makes something linear? A linear relation occurs when the graph of the relation set forms a straight line. So we have a graph here, and we plotted all the points that they gave us, and when we did that, it forms a straight line. That's a linear relation. Notice that as the x values change by 1, the y values change by the same amount each time. Meaning that as we go through, it keeps stepping up the same amount each time. How to read a table? The columns are the vertical cells in the table. So this is a column and this is a column. And then we have rows, which are the ones that go horizontally or side to side. These are our rows. We always label the columns. So in this case, we're calling this one time in months and this one temperature in degrees. And then we put in our table. So we fill it in with the data points. Now the columns separate the two variables. So this separates time from months. And the rows separate the actual data. So this is a data point. This is a data point. This is a data point. And this is a data point. So in this case, we're going to try to recognize what pattern we see in the columns. So if we look here at the time, we see that each time we go down one level on the rows, that we're adding 1. So we could say that time is moving up from one row to the next, and the pattern is consistent, right? We didn't have add 1, add 2, and then add 1. We're consistently adding 1. Next, let's look at the temperature. Well, is there any kind of pattern here? Well, from here to here, we're adding 5, and then adding 5, adding 5, and adding 5. So therefore, the temperature is moving up by 5 from one row to the next, and the pattern is also consistent. So the temperature is going up by 5 degrees every 1 hour. That's what we can say based on the pattern we see from the table. Now from that, can we tell if these patterns are linear or not? Well, if the changes in the data are consistently changing by the same amount, and that amount is in the form of addition, it is a linear relation. So let's take a look at the table. So we have our months, and we look and see that there is a steady change. We're adding by 1 month each time. And in rainfall, we can see that we have a consistent change also. We are adding by 2 inches each month. Therefore, if we were to plot these points, it would look like this, and therefore we can see it does form a straight line, and yes, it is linear because we have a consistent change of addition and a consistent change of addition. Let's look at another example. So we have our months here, and we can see that they are adding by 2 each time. So therefore, yes, there is a consistent change. In this case, we're adding by 7, and then 7 again, and 7 again. So yes, there is a steady change, and it changes by 7 home runs. So therefore, is this linear? Well, we have a consistent change of addition, and we have a consistent change of addition here. So therefore, this is linear. Now we can take a look at it another way in terms of perimeter. So this is kind of a geometric application to this. So if we have the perimeter of this block here, we know that this side is 2 and this side is 4. So now we're going to see that this side is also 4 and this side is 2. We know that perimeter means the sum of all the sides, or adding up all the sides. So this is 4 plus 4, which is 8, plus 2 is 10, plus 2 is 12. So that's my perimeter for the first one. Now we do it for this one. This is 2, and this is 4. So that means this side also has to be 4, and each of these sides has to be 2. So that's 2, 2, and 2. So if we add all these up, this is 4 plus 4 is 8. Plus 4 is 12, plus 4 again is 16. And then again, we add these up. This is 4 and 4, and then 2, 2, 2, and 2, 2, 2, and we get 20. So now, if we were to do this by the number of rectangles and the perimeter, so this is one rectangle here, which was a perimeter of 12, 2 rectangles was a perimeter of 16, and 3 rectangles is a perimeter of 20. Therefore, we want to know, is this linear? Well, we're adding by 1 each time here, so that's consistent and addition. We're adding by 4 each time here, that's consistent and addition. So yes, it is a function, and it is linear. Let's take a look now at the Introduction to Functions assignment. If you look at the assignment, at the top of the page, we have our learning goals and success criteria here. If you continue to scroll down, it asks the questions on functions. So the first question says, which of the following notations are equivalent to the function below? So we have y equals 2x minus 4. Well, what we should notice from our notes is that y and f of x mean exactly the same thing. So we don't change anything, we just change y to be f of x. So it should say f of x equals 2x minus 4. Well, this one says f of x equals 2x minus 4, so we'll go ahead and mark that as our answer. Then we move on to the next one. Which of the following notations are equivalent to the function below? Well, we have f of x is equal to negative x plus 15. Again, y and f of x mean the same thing, so we're just going to change f of x to be y. So it should say y equals negative x plus 15, which is this one here. And you'll continue to answer each of these questions all the way until you get to the bottom of the page. Once you get to the bottom of the page, you're going to go ahead and click Next. That will send you to your Before You Go. You'll fill out your Before You Go and then submit your work on Google Classroom.